Hello everyone, my name is Aaron Martin, and today I'll be presenting an article titled Data-Driven Approaches for Predicting and Optimizing the Compressive Strength of Self-Compacting Concrete. The purpose of this study was to investigate how data-driven methods can be used toward predicting the compressive strength of self-compacting concrete. The researchers of this study actually compared adaptive boosting, which is a modern machine learning technique, with multiple linear regression, a more, I guess you could say, traditional method. Their goal was not to just improve the accuracy, but also provide practical tools for engineers and researchers. For the methodology, I chose that the researchers actually collected 99 records from different previous studies. They inputted different variables such as cement, fine aggregate, and water. These researchers also focused on how these factors influence compressive strength in this study. In the analysis, they had applied adaptive boosting and multiple linear regression in this data set, to the data set. They had measured model performance using R-squared values and metrics. They had also used visualization methods and partial dependence plots to highlight which factors had the most influence on the compressive strength. Their reliability confirmed with tenfold cross-validation and Monte Carlo simulations. The results and conclusions actually showed that the adaptive boosting outperformed and, I guess, did better than the multiple linear regression. The cement and fine aggregate were the most critical factors when used in this study. It was also shown that the fiber had little influence on this study, and the researchers didn't really know how. For future research, and what stood out to me the most was the performance of the adaptive model. For future research, I wanted to, I guess, ask the question of how would these models perform in actual real-world construction conditions, I guess. I would like to see and maybe see a follow-up study of, how these models could be tested on larger data sets or larger sites in the construction projects, just to see how they'd be used in real world scenarios, which I would find that really interesting. So, thank you all for listening, and